This lesson is about comparing expressions with exponents. So when we have the same base, it is pretty easy to compare numbers. So let's take a look at some basic examples. First of all, I want you to try to think of 3 different expressions that are equivalent to 2 to the 13th power. I would like 3 different expressions that are equivalent to 2 to the 13th. So one example would be 2 to the 10th times 2 to the 3rd. That's equivalent to 2 to the 13th based on the properties that we have studied. Another one could be 2 to the 13th is equivalent to 2 to the 20th divided by 2 to the 7th. And that is because when we have 2 to the 20th over 2 to the 7th, we subtract the exponents, and that gives us 13 as the new exponent. So I would like for you to come up with 2 more, one using the same property as the first example, and the second using the same property as the second example. So 2 to what power times 2 to what power? So you're filling in the blanks there. And then the last example here, 2 to the 13th is 2 to, and you fill in the powers there, 2 to the what power? So try those on your own. Next, alright, moving on to comparing. If we have 3 to the 6th, and we want to compare it to 3 squared times 3 to the 3rd. Comparison means we use the less than symbol, the greater than symbol, or the equal to symbol. So in order to compare these, we would use our properties to simplify that. With the properties, we know that we should add the exponents in this case, so it's 3 to the 5th. So 3 to the 6th compared to 3 to the 5th, the correct symbol would be the greater than symbol. A second example is 1/4 to the 16th power compared to 1/4 to the 8th times 1/4 to the 2nd. So, a couple different properties we're going to use here. The first one is the power of a quotient property, where we apply the exponent to both the numerator and the denominator. So our new expression is 1 to the 16th over 4 to the 16th. On the other side, we have the same base. 1/4 is our base. So we are going to add the exponents, and we have 1/4 to the 10th. Then we would apply the power of a quotient property, and that would be 1 to the 10th over 4 to the 10th. Now, 1 to any power is simply 1. So we have 1 over 4 to the 16th power compared to 1 over 4 to the 10th power. Now, if we ignore the fraction and just compare 4 to the 16th and 4 to the 10th, 4 to the 16th is bigger. But when the denominator is bigger and the numerator is the same, that means the one with the bigger denominator means the value is smaller. So the correct symbol is the less than symbol. The next part is a little bit more difficult because I'm going to give you problems that don't have the same base. But without getting into high-level mathematics, we need to get the same base in order to compare them. So let's take a look at 5 to the 28th power compared to 25 to the 19th power. Now, without using a calculator, we could compare these by getting the same base. Now, when I'm talking about the base, that is the big number of a power. So 5 is the base here, and 25 is the base here. So since 25 is a power of 5, we can rewrite this using the same base. So I am going to think to myself that 25 is equivalent to 5 squared. So I'm going to replace the 25 with 5 squared, and that is being raised to the 19th power. Now I can use the power of a power property and multiply the powers. 2 times 19, so that's 5 to the 38th power, and over here we have 5 to the 28th power, and now it is easy to compare. 5 to the 28th power is most definitely less than 5 to the 38th power. Let's try another one. 3 to the 18th power compared to 9 to the 10th times 3 to the 3rd. So again, we're looking at the bases, 3, 9, and 3. We want all the bases to match up, so I'm going to change that 9 to be 3 squared. So I have 3 squared raised to the 10th times 3 to the 3rd. Then we're going to use the power of a power property and multiply the exponents there. So we get 3 to the 20th times 3 to the 3rd. Then I'm going to use the product of powers property, where we add the exponents when we have the same base. So we get 3 to the 23rd power. Over here we have 3 to the 18th power. So that makes it easy to compare. 3 to the 18th is less than 3 to the 23rd power. And let's do one more. 4 to the 21st power compared to 2 to the 28th power times 8 to the 4th power. So, compare the bases, 4, 2, and 8. Those are all powers of 2. 4 is equivalent to 2 squared, and 8 is equivalent to 2 to the 3rd power, or 2 cubed. So I'm going to use those facts to help me on this problem. I'm going to rewrite 4 as 2 squared, and that is being raised to the 21st power. Power of a power property tells me I should multiply the exponents, so this side becomes 2 to the 42nd power. On the other side, I already have a base of 2 for the 2 to the 28th, so I'm not going to change that. And then 8 I'm going to replace with 2 to the 3rd because that's equivalent, and raise it to the 4th. Now I have a power to a power property, power of a power property. So I multiply those exponents. I have 2 to the 28th times 2 to the 12th. And then I have the product of powers property that tells me I should add the exponents when I have the same base. So this becomes 2 to the 40th power. And over here we had 2 to the 42nd power. So 2 to the 42nd power is greater than 2 to the 40th power. So in summary, we need to get the same base and use power properties of exponents, to compare.